Here we have an example of a situation where we have pollution, an external cost, and that external cost is not constant, it's increasing with production. So you can see that our marginal external cost here is not just a number, it's a function of the quantity that's being produced. So again, we're going to just start with our market equilibrium. We'll plot our supply and demand curves. So we got 130, 65 for demand, and then let's see, 10 plus Q for supply, and our market equilibrium quantity, we'll set those equations equal to each other, and we get that Q is equal to 40. And we could find P here. That's, 50. All right, so this is where we're going to end up if we have an unregulated market and we know it is not socially optimal. And to see that, we can plot our marginal social cost curve. That will be the sum of the private cost plus our external cost. So that's going to be 10 plus 3Q. So we'll start here at 10 like before, and then go up. Oops, that's our marginal social cost curve. So here's the market equilibrium. And here is our socially optimal point. And I need to extend this line just a bit here because we want to know what is the external cost at the market equilibrium. Okay. That does not seem straight. Okay, so great. We have plotted our supply curve, our private cost, our demand curve, our private benefit, and our marginal social cost curve. So now the socially optimal quantity, and that's always going to be where your marginal social cost curve is equal to your marginal social benefit curve. Okay, whereas here we had our private marginal benefit equal to our private marginal cost. Okay, so we have no external benefit in this case, so demand can represent our social benefit, right? So our socially optimal point is here. To get that, we will set marginal social cost equal to demand. So we get 5Q equals 120. So Q will be equal to 24. Sorry, on the wrong page. 24. Okay, again, I don't typically ask you to solve for prices in this case because there are two different prices that get us to a quantity of 24. And so we'll just leave that off. All right, then the next question is how much deadweight loss is there in this market? And you can see, right, we want to think about what is total surplus at the market equilibrium like compared to total surplus at the socially optimal point. So if we produce all the way out to 40, the problem is that the cost of that production is higher than the benefit of that production. And this triangle here will represent our deadweight loss. So we're going to take the height is the marginal external cost at a quantity of 40. So we'll find marginal external cost at Q equals 40. And then the width of the triangle is the difference in quantities. So this is 2 times 40. I'm just plugging that into my equation for marginal external cost. I get 80. That's the height of the triangle. Sorry about that. And so marginal external cost is equal to 80. And then we can calculate that deadweight loss triangle is 1/2 times 80 times 40 minus 24. Okay. And that will give me 640. Okay. So that's my deadweight loss from the uncorrected negative externality. So total surplus is $640 lower at the market equilibrium than at the socially optimal quantity of 24. So now we're going to think about how the government might approach solving this problem, right? So the problem is that we're producing too much because people don't take into account the cost of their actions. Well, the fundamental problem here is that people don't take into account the cost of their actions, and we need to force them to do that. So we can just take that external cost and force the consumers and producers to internalize it to their market decisions. So how could we do that? Well, we can have a tax on this product that is equal to the marginal external cost, right? So that's going to force the consumers and producers to take into account their the actual cost of their actions. Okay, now this situation is a bit tricky because the marginal external cost is not constant. So like, what do we set the tax equal to? So here, what we want to do is set the tax equal to the marginal external cost at the socially optimal quantity. You might remember from intro that when you have a tax, you shift the supply curve up by the amount of the tax, right? So if I here look at the marginal external cost at the socially optimal quantity, and then I shift my supply line up by the amount of the tax. Okay, so I've got supply plus tax here. Then we're going to pass directly through that socially optimal point. Our new market equilibrium with the tax would be equal to the socially optimal quantity. So in this case, in order to find what this tax should be, what we would need to do is to calculate the marginal external cost at the socially optimal quantity, which would be 2 times 24, giving us a tax of $48 per unit. And we're here using the per unit tax as a simplified version of a tax, but it's actually quite realistic in markets with externalities. So the way that we would say tax carbon would be to issue a tax per unit of emissions. And so that graph where we just shift supply up by the amount of the tax is pretty representative of how we would approach that problem. Okay, so this is actually called a Pigouvian tax. So if you hear people talk about that, that's what this means. And this is really analogous to the subsidy that we talked about when we were looking at the positive externality problem. Okay, so this is one option, right? One option is to have a tax, and that forces the private consumer and producer to internalize the external cost of their actions. Another way to do this would be to simply limit the quantity that's being produced, right? The problem is we're producing too much. Here we're producing 40 units when the socially optimal quantity is 24. So we could just say we can't produce more than 24 units, okay? So that would be a simple quota, and that quota would then be equal to, set equal to the socially optimal quantity. Well, the problem with this is that it doesn't really give firms an incentive to go above and beyond. So we're thinking again about global warming or pollution regulation. If I tell them, well, you can emit this much, well, they'll just emit that much. But with a tax, they have an incentive to try to come up with new technologies that allow them to produce more while reducing their emissions, so that they could be more profitable. So that incentive of a market-based solution like a tax, I think is superior to the quota system. And the way that we can incorporate quotas into a more market-based system is to have a system of cap and trade. So a cap and trade system basically sets a quota for the total emissions, caps emissions, but then issues permits for emissions to firms and allows them to trade with each other. And by setting a market price for emissions, it again gives firms an incentive to reduce emissions as much as possible, reduce emissions in areas where it is most efficient to do so, and come up with new technologies to produce with lower emissions. So generally, economists prefer these kind of market-based solutions to like a more command and control, like you will do this kind of solution. But there are many different ways to approach solving these negative externality problems.